Hello dear students, today we are taking the new chapter, second chapter, unit and measurement. Okay, now in this chapter we will study about the physical quantity, its unit, and what is the measurement, how we can take the measurement. So generally in our day-to-day life we are taking so many events takes place around us. So we observe many phenomena occurring in our surrounding, like a fruit falling from the tree, then a satellite is revolving around the earth. So these are the different phenomena we are taking around us. Now, to understand this natural phenomena, we should know from which height does the fruit fall, how much time does it takes place to reach the ground, what is the speed of the fall of the fruit, etc. So, to answer all this question, we need to measure physical quantities like the distance, time, speed, mass, etc. accurately. So, for measurement of any quantity, we require to decide their appropriate units. Let us understand it briefly. The standard measurement of any quantity is called a unit of that physical quantity. So unit is what? It is the standard measurement of any quantity. Suppose if you are taking the length, you say that the length of this road is 20, then no one can understand these things. If you say that the length of this road is 20 meter, then one can understand it easily. So unit is the standard measurement of any physical quantity. How should the unit be of the physical quantity? So first of all, the measurement of the unit should be definite and unambiguous. The unit, its measurement should be definite. It is sure. It is definite unit. The unit should be such that its measurement should not change, and if any phenomena takes place, then that phenomena must be permanent. That means, suppose if you are taking the one scale and you are measuring one road's length, suppose it is the 4 centimeter, then by taking any other scale, if you measure this length, you will get the 4 centimeter. At any places, at any temperature, at any pressure, we will get the same measurement like a 4 centimeter. Okay, but some phenomena takes place around us in which some physical quantities are getting different value and different unit. So that phenomena must be permanent. Suppose if you are taking the gravitational acceleration of the object. So generally we know that g is equal to 9.8 meter per second square on the earth ground, or on the surface of the earth. But if we take the gravitational acceleration of the object on the north pole or the south pole of the earth, then it may varies. So when you go from latitude or from altitude, then at place to place the value of the small g is changing. So that change is permanent. If you say that on the pole the value of g is this, then it is the permanent value, though it is differ from the equator of the earth. Another example for the how should the unit? For that we can take that the prototype or the replica of the unit should be easily reproducible and easily available. Suppose we are taking the scale, the length. So for that length we are taking the scale and it is the one replica. You can make the scale easily by using the another material. So the prototype, replica or the model of the unit should be easily reproducible or easily available. Now another point we are taking, that is the unit of physical quantity and system of units. Although the number of physical quantity is very large, we need only a minimum limited number of physical quantities for which unit should be the unit of all other quantities can be expressed and defined with their help of them. So we are taking so many number of quantities around us in the science. Now out of all these quantities, if you take most of the quantities, they are made from some basic quantities, some limited number of quantities. Suppose if you are taking the speed, then it is made from the distance and the time. Speed equal to distance upon time. Acceleration, acceleration is equal to speed upon time or the velocity upon time. Then it is the distance upon time square. Same way we can take the force, it is the mass into acceleration. So here we are taking the limited number of the quantity. This limited number of the quantity or selected number of the quantity is known as the base quantity or the fundamental quantity, and their unit is known as the base unit or the fundamental unit. So we have a 7 fundamental quantities. Most of we are using the mass, length, time, then the temperature, current, amount of the substance, luminous intensity, etc. So the minimum physical quantity are known as the fundamental quantity or base quantity. Their unit is known as the base unit or the fundamental unit. We can take the example length, time, mass, current, temperature, amount of substance, luminous intensity. Now another point, that this is known as the fundamental quantity. Now there are another two type of the quantity out of so many number of quantities. So that type is known as the derived quantity, and another is the supplementary quantity. Derived quantity, what is the meaning of the derived quantity? Derived quantity, that is the quantity which can be derived from the fundamental quantities. If we take the speed, then it is the derived quantity. It is made from the distance and the time fundamental quantity. So the other physical quantity can be expressed as a combination of fundamental quantities. Such physical quantities are called derived quantities, and their unit is known as the derived unit. So most of all the quantities we know around us, most of that are derived quantity, and their units are derived units. So we can take the example speed, work, then pressure. These are the derived quantity. Force is also derived quantity. So we can take the unit of this quantity, like a speed. For the speed it is the meter per second. For the force it is the mass into acceleration, that is the kilogram meter per second square. For the pressure we are taking the Newton per meter square. For the work we are taking the force into distance, that is the Newton into meter. So these are the derived quantity, and their unit are derived unit. Now different system of units. See, we are taking any quantity, the quantity's unit can be expressed in terms of some system. So there are the different system of units. First of all, the first system is known as the FPS system, foot, pound, second. It is the British system. So another system is known as the CGS system, centimeter, gram, second. So centimeter, that is the unit of the length. Gram, unit of the mass. Second, unit of the time. Same way, here foot, it is the unit of the length in the British system. Pound is the unit of the mass, and second, it is unit of the time in the FPS system. MKS system is the meter, kilogram, second system. Meter, unit of the length, then kilogram, unit of the mass, second is the unit of the time. Another is the MKSA. We are using this system of the unit in the electricity magnetism field. So it is the meter, kilogram, second, ampere. Then another is the SI unit. What is the SI unit? It is the system international unit. So we have so many number of physical quantity. To express their units, sometimes for one quantity we can have so many units. Suppose if you are taking the force, then force has a unit kilogram meter per second square. Same way for the force we are taking the Newton or the dyne unit. So SI system, that is the system of the units which is at present internationally accepted for measurement, is the system international units. There are the 7 basic units. So SI units, in that SI units we are taking the base quantity, their name and their symbol, which is given in this table. That is, for the length the name is meter of the unit, symbol is the small m, then time is the second, s, mass kilogram, kg, electric current ampere, capital A, thermodynamic temperature Kelvin, capital K, amount of the substance, their mole, and symbol is the mol. The luminous intensity for the light is the candela, candela, and its unit symbol is the CD, small cd. Then we are taking the definition of the derived unit. So all the other units of different physical quantities can be expressed as a combination of the 7 base units of the SI system. Then such units are called the derived units. And for example, we can take the speed, the unit of the distance upon unit of the time. So it is the meter per second. And we are taking the another types is known as the supplementary quantity. In this textbook, the supplementary quantity or the supplementary units are not mentioned, but for your information, there is a special type of the quantity in the physics is known as the supplementary quantity. So supplementary quantities are special quantities specified in physics. For example, plane angle, solid angle, radioactivity. So their unit is known as the supplementary unit. For the plane angle, the unit is given as the radian. Symbol is rad, small rad. And for the solid angle, the unit is steradian and the symbol is SR. Here in this picture, the definition of the plane angle and the solid angle is given with the pictorial diagram. So we know plane angle, that is the angle, simple angle, arc upon radius, and we are taking the unit, its SI unit is taken as the radian. So generally we are taking the degree unit for the angle, but we have to write it in terms of the radian because radian is the SI unit here. So it is the supplementary units. So the supplementary unit of the quantity radioactivity is taken as the Becquerel or the Curie. So you will learn about the radioactivity in the standard 12. Now there are the practical norms for the use of the SI system. So what are the practical norms of the use of the SI system? It is very important while you are writing the units of the physical quantity in the physics. So first is the unit of every physical quantity should be represented according to its symbol. Suppose if you are writing the meter, then the symbol of the unit of the length is taken as the small m, not the capital M. Another point, no full stop should be used within or at the end of the symbol of the unit. For example, kilogram. that is the unit of the mass, we can write the kg, but you cannot write it is as a kg dot or k dot g dot. Okay, no full stop is coming while writing the unit. Third one is the symbol for units do not take plural form. For example, meter is used to denote many meters also. If there is a length of the road is 100 meter, then in the subject English we are writing as a meters. We are putting the s after the meter. But here in physics, the meter is the unit and it is expressed as a small m only, not ms. Fourth point, the unit of the physical quantity in numerator and denominator should be written as 1:1 only. For example, the SI unit of the acceleration is written as meter per second square, or you can write meter second raised to minus 2, means small m s raised to minus 2. But you cannot write it as a m by s by s. It is the many ratio, so it is not allowed. So the ratio should be 1:1, meter per second square or meter second raised to minus 2. Fifth point, full name of a unit when it is named after a scientist is not written with a capital letter, but the symbol for that unit has a capital letter. Suppose we are taking the example of the unit of the force quantity. The force quantity, that is its unit, is written in the honor of scientist Newton. So we have to write the Newton name in small letter, small Newton, small letters. But if you want to write with the capital, then its symbol is taken as the capital N, only first letter, that is the capital letter, as a unit or as a symbol of the unit. Then if you are writing the unit of the pressure, the unit of the pressure, it is also in the name of the scientist, and the Pascal is written as the small capital P small a. So it is written as the PA, where first letter is capital P and other letters is small, so small a, PA. Okay, in the next session we will study about the measurement of the length, time and the mass quantity in the large scale as well as in the small scale. Thank you.